In a daring announcement, researchers have revealed the identification of a completely new planet unlike any other discovered before. NASA, renowned for its trailblazing research, has shared that this newly uncovered planet is fascinating not just due to its size and location, but also because it radiates light that seems to be artificial. Could this revolutionary find signify that we are on the verge of unlocking secrets that will radically transform our understanding of the universe? Does this spark curiosity about the potential for life on planets beyond Earth? As we dive into NASA's incredible revelations, we may soon uncover the truth behind these extraordinary illuminations. In 2007, NASA launched the Dawn probe with the objective of investigating some of the most intriguing objects in our solar system. Equipped with 3 ion propulsion engines, Dawn began a mission that kicked off with a 14-month survey of Vesta, the second-largest asteroid in the belt. Dawn transmitted back detailed pictures and data, unveiling Vesta's complex surface and rich geological history. Upon completing its assignment at Vesta, Dawn proceeded with what was arguably the most thrilling phase of its journey, an in-depth exploration of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a task that traditional chemical propulsion methods could not have achieved. These engines provided a steady thrust, allowing Dawn to cover immense distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object within the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, making it one of the most fascinating objects due to its unique features. Scientists eagerly anticipated the first high-resolution images of this mysterious world, which revealed bright spots scattered across its surface, particularly inside a large crater called Ocata crater. These luminous spots instantly captured the attention of the scientific community. Before the Dawn mission, the best pictures we had of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Little was known about the dwarf planet, and the prospect of receiving close-up images promised exciting new insights. The Dawn mission aimed to deepen our understanding of the solar system's formation and the role that water played in shaping planetary bodies. The bright spots on Ceres, which were also noticed on other asteroids, were thought to be composed of highly reflective materials, likely salts left behind by evaporated water. This discovery suggested the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes expel not molten rock, but liquid water or brine. What exactly these enigmatic lights are and what they reveal about Ceres remains an open question. Could they be signs of ongoing geological activity? Or might they indicate something even more astonishing? Ceres stands apart from other bodies in the asteroid belt due to its size, mass, composition, and potential for harboring water and ice. Unlike typical rocky asteroids, Ceres is made up of a mixture of water, ice and volatile materials, which means it may hold valuable secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a crucial moment in its mission as it prepared to send back the first close-up images of the largest object in the asteroid belt. The spacecraft drew nearer to Ceres, unveiling a world previously hidden from view. The initial pictures of Ceres displayed a cratered surface, indicative of a long history of impacts. However, it was the bright spots scattered across the dark, rocky terrain that seized the attention of scientists and space fans. As the resolution of the images improved, scientists proposed various hypotheses about these spots. Could they be patches of ice reflecting sunlight, or could they represent something even more unusual? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer scrutiny revealed that the brightest spot was not a single feature but a cluster of several distinct spots. The most widely accepted explanation was that these spots were deposits of salt left behind by the evaporation of water. This suggested that Ceres may have, or still does have, some form of geological activity capable of bringing water or brine to the surface, where it quickly sublimates, leaving behind bright, reflective residues. These revelations challenged prior assumptions about Ceres, providing a fresh perspective on a dynamic and complex world. The possibility that groundwater or brine pockets exist beneath the surface raises exciting questions about the potential for life elsewhere in our solar system. Ceres is often described as an icy world with a rocky yet porous exterior. Unlike most asteroids, which are composed primarily of rock and metal, Ceres stands out for its unusual makeup. Its surface is made up of a mixture of water, ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition implies that Ceres contains a substantial amount of water. Its rocky surface is porous, with ice and other volatile substances trapped inside, making it more like a comet than a typical asteroid. Scientists believe that Ceres has a unique interior, consisting of a muddy mantle and a core rich in water ice, which constitutes about 50% of its total volume. The mantle is thought to be a blend of rock and brine, encasing a core potentially made of denser materials like silicates. The presence of significant water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was warmed by radioactive decay early in its history. This interior structure distinguishes Ceres from other asteroids and raises fascinating questions about its potential for geological activity and the role of water in its development. Moreover, the discovery of ammonia clays on Ceres points to the possibility that the dwarf planet may have originally formed in a cooler region of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, supporting the existence of surface brine. These insights into the composition and history of Ceres not only deepen our understanding of this captivating dwarf planet but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a captivating and relatively rare geological phenomenon, especially when compared to the more familiar volcanic activities on Earth. Unlike traditional volcanoes that eject molten rock, cryovolcanoes are often referred to as ice volcanoes, as they release substances such as water, ammonia, or methane. These materials can exist as liquids or gases in extremely cold environments, such as those found on Ceres. Cryovolcanoes on Ceres operate by allowing salty water with dissolved minerals to reach the surface. When the salt water comes into contact with the vacuum of space, it rapidly sublimates, turning directly from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots seen on Ceres. Among the most captivating features observed by Dawn was Ahuna Mons, a massive, solitary mountain that rises starkly from Ceres' surface. Unlike typical mountains formed by tectonic or impact processes, Ahuna Mons appears to be a cryovolcano, suggesting a relatively young geological age. Its flanks are smooth, and it lacks the heavy cratering seen in surrounding regions, implying it may have formed within the last few 100 million years. This challenges the idea that small celestial bodies are geologically dead and positions Ceres as an unexpectedly dynamic world. Ahuna Mons, standing about 4 kilometers high, is composed of salt-rich material and shows signs of flow features, evidence that briny liquid may have erupted from the interior and frozen upon reaching the surface. These cryovolcanic processes, if confirmed, would make Ceres the most volcanically active dwarf planet in the inner solar system. The possibility of subsurface reservoirs of briny water beneath Ceres' crust adds another layer of intrigue. The existence of such reservoirs has fueled speculation about habitability. Though the conditions may be harsh and cold, the presence of water, one of the essential ingredients for life as we know it, raises the tantalizing question: could microbial life exist, or have ever existed, beneath Ceres' surface? Dawn's spectrometers also detected organic compounds in several locations, including Ernutet crater. These carbon-based molecules are the building blocks of life. While their presence doesn't confirm biological activity, their origin, whether internal or delivered via cometary impacts, adds Ceres to the list of solar system bodies with astrobiological potential, alongside Europa, Enceladus, and Mars. Perhaps even more fascinating were the mysterious transient hazes that scientists observed within the Orcata crater. These hazes appeared to form during Ceres' daytime and faded at night, indicating a possible diurnal atmosphere, however thin. Researchers believe the haze may be the result of sublimating ice or brine, forming a temporary exosphere. This kind of activity is highly unusual for a body of Ceres' size and location, reinforcing its uniqueness in the solar system. As Dawn orbited closer, scientists noticed that the bright spots within Orcata crater weren't uniform. Instead, they were made of different types of salts, primarily sodium carbonate, suggesting multiple episodes or mechanisms of brine release. These discoveries hinted at a complex hydrogeological history, possibly involving a long-lived interior ocean. By the end of its mission in 2018, Dawn had profoundly altered our understanding of Ceres. It showed that this seemingly modest dwarf planet is not a static chunk of rock and ice but a geologically active world with water, organics, and potentially ongoing internal processes. But Dawn's mission also raised new questions. How long has cryovolcanic activity persisted on Ceres? Are the bright spots still being replenished? Could there be microbial ecosystems in subsurface brines, protected from the harsh vacuum of space? And perhaps the most provocative question of all: are we alone, or have we just scratched the surface of a deeper truth? Ceres, with its enigmatic lights and hidden depths, challenges our assumptions about where life could emerge. It invites us to look beyond the traditional Goldilocks zone and reconsider what environments might harbor life, not just warm, Earth-like planets, but cold, briny worlds teeming with chemical potential. As future missions are planned, some potentially equipped to drill or sample Ceres' surface, we may be standing on the cusp of one of the greatest scientific discoveries of our time. And if artificial-looking lights are ever confirmed to be more than just salt reflections, well, then we may need to redefine everything we think we know about being human in this universe. Remained captivated by the planet's enigmas, each new discovery raised more questions about the dwarf planet's past and its potential to support conditions conducive to life. The presence of bright spots and signs of cryovolcanism painted a picture of an active world far more dynamic than originally believed. This discovery suggested that Ceres might not only be a relic of the early solar system but also a planet where ongoing geological processes, such as the eruption of ice and brine, are still shaping its surface. The fact that Ceres could maintain such activity despite its small size challenges conventional thinking about celestial bodies in the asteroid belt. Traditional beliefs held that small bodies, especially those located in colder regions, were likely to be geologically inactive and frozen in time. However, Ceres' ongoing activity suggests that even in the cold, distant reaches of the solar system, the right combination of heat, water, and salts might be enough to drive cryovolcanic eruptions. Another important aspect of Ceres is its potential to reveal key information about the history of water in the solar system. Water is a crucial element for life as we know it, and the discovery that it may exist in liquid or brine form on Ceres opens up new possibilities for the existence of life in environments far from the warmth of the sun. The idea that water ice, and even liquid water, could have once existed on Ceres suggests that other similar bodies in the solar system, such as Jupiter's moon Europa and Saturn's Enceladus, may also harbor conditions favorable for life, making them prime targets for future exploration. The possibility of cryovolcanism occurring on Ceres also raises further questions about the mechanisms that drive such activity. How does the water beneath Ceres' icy crust remain in a liquid state despite the freezing temperatures of space? Could there be an internal heat source, such as radioactive decay or tidal heating from gravitational forces, that keeps the water beneath the surface warm enough to remain liquid? Understanding the nature of these internal heat sources could offer valuable insights into the geological evolution of other icy bodies in the solar system. Ceres' dynamic surface features, from its bright spots to its craters, help us better understand the impact history of the solar system and the ways in which smaller bodies have evolved over billions of years. Every crater on Ceres, each distinct in its formation, gives scientists a glimpse into the forces that have shaped not just Ceres, but many similar bodies throughout the solar system. Whether these impacts were caused by asteroid collisions or other cosmic events, they contribute to the unique character of Ceres and its role in the broader narrative of the solar system's development. Moreover, the presence of ammonia clays on Ceres offers another captivating clue about its history. Ammonia is known to lower the freezing point of water, which could have allowed liquid water to exist on the surface in the past, or even today. This discovery suggests that Ceres may have originated in the colder outer regions of the solar system before migrating inward toward its current position. This migratory history could explain many of the intriguing features seen on its surface, including the presence of ammonia and signs of cryovolcanism. As scientists continue to study Ceres' surface and interior, their findings are reshaping our understanding of planetary formation, the potential for life beyond Earth, and the processes that drive geological activity in the outer solar system. Ceres, once considered just another small, cold asteroid in the belt, has emerged as a captivating world that defies our expectations and invites us to reconsider what is possible on distant worlds. The Dawn spacecraft, through its years of careful observation, has played a crucial role in uncovering these new details about Ceres. The mission, which has delivered the most detailed images and data of this faraway dwarf planet, continues to be a cornerstone in our exploration of the solar system. Each new image transmitted back from the spacecraft reveals more of the planet's secrets, showing a complex and ever-evolving world that was once largely unknown. These discoveries are only the beginning of what promises to be an ongoing exploration into the mysteries of the outer solar system. In the years to come, the scientific community will undoubtedly continue to analyze the data sent back by Dawn, searching for more clues about the potential for life on Ceres and similar bodies in the solar system. As technology advances and new missions are launched, even more unexpected revelations are sure to come. Will we uncover more signs of cryovolcanism or discover even more evidence of water beneath Ceres' surface? Only time will tell. But one thing is for sure, the story of Ceres is far from over. As researchers continue to examine the wealth of data provided by the Dawn mission, new models of Ceres' interior structure are beginning to emerge. These models suggest the presence of a partially differentiated core, with a muddy or briny mantle that could allow for the persistence of subsurface reservoirs. If confirmed, this would place Ceres among the select group of celestial bodies in the solar system believed to have subsurface oceans, an exciting and unexpected revelation for a world of its size and location. Moreover, the unique chemistry observed on Ceres sets it apart from other objects in the asteroid belt. Spectral analysis of its surface has revealed organic compounds, complex carbon-based molecules that are considered essential precursors to life. While these organics may have formed on Ceres itself, there is also a possibility that they were delivered via cometary or asteroid impacts. Either origin points to a rich and chemically diverse environment that deserves closer study. The scientific implications of these findings extend beyond the study of Ceres itself. They challenge traditional assumptions about the kinds of environments in which life might emerge or be sustained. If a small, cold body like Ceres can possess the necessary ingredients for life, including water, organics, and energy sources, then perhaps the conditions for life are more common in the cosmos than previously believed. Ceres also represents a valuable stepping stone for future exploration missions. Its relatively close proximity to Earth and its unique composition make it an ideal target for robotic landers and, eventually, sample return missions. By analyzing material directly from its surface, scientists could gain unprecedented insights into the chemical and physical processes that shaped the early solar system. Looking even further ahead, some researchers have proposed that Ceres could one day serve as a base for deep space missions. Its abundance of water ice could be harnessed for life support or converted into rocket fuel, potentially supporting human exploration deeper into the solar system. Though such ambitions remain in the distant future, they underscore the growing recognition of Ceres' importance in our quest to understand, and one day venture beyond, our planetary neighborhood. In many ways, the story of Ceres is a testament to the power of curiosity and the value of sustained exploration. What began as a fuzzy point of light through a telescope is now recognized as a complex and compelling world, one that continues to challenge our understanding of the solar system and inspire new generations of scientists, engineers, and dreamers. As we stand on the threshold of new discoveries, Ceres reminds us that even the smallest worlds can hold the biggest secrets.